Okay, guys, once again, I welcome you to my lesson for today, where we'll be looking at all of this that I've written down. So, Prudence, this is a grade 10 lesson, but I wanted you to join this lesson so that you are able to see my teaching style. And again, just so that we prepare you for the next lesson, which will start at 8:15, which is for grade 11 and 12, where I'll be doing physical sciences. So this is a continuation of what I've been doing with Mr. Kele and Shreyas. So you can just be watching what we'll be doing. So Kele and Shreyas, for today's lesson, this is what we'll be looking at. And I just want to make sure that before we move to the next chapter, you fully understand and again, you are confident with approaching this type of questions. Remember, it's not really about you being able to solve or answer these questions, but what matters the most is the approach. So I think Shreyas and I, when we started, we dealt with this type of problems. This is what I wanted to teach you once we finished that type of a problem. And again, also this one, this is also what I wanted to teach you. And also there we've got a simultaneous equation, but you seem to be having an idea because I think you are able to now solve some math-related problems. So this is another type of a factorization that I was talking about, where I was saying I need to also teach you that type because we've already done this type of factorization. But most importantly, I'm more interested in teaching you the approach, not necessarily how to solve this type of problems. So, guys, I think most of the time, what I'll be doing is to answer maybe, let me say, I'm going to try and answer all of those questions. Then from there, I'm going to give you an opportunity to try different problems. So on the first one, we've got -4 minus p. This was equated to 4. So I hope I've copied it correctly. Also, as you can see over there, it's -4 minus p. It's equals to 4. And remember, guys, all of this, I just wrote them now out of my head. It's not like it comes from a textbook or somewhere. So, Shreyas, based on what we discussed initially when we started, or maybe let me ask Kele, because I'm not sure if he was with us when we started with our lesson from our very first lesson. Kele, what can you say about this type of a problem, or what is that in terms of you explaining whether it's an expression or an equation? Do you still remember? Are you aware of it, or would you like Shreyas to just go for it? Okay, so I'm not sure if Kele got that, but Shreyas, can you go for it?
Yes, sir. So this is
Okay.
an equation.
Mm-hmm.
We have to solve for the unknown, which is represented as p.
Mm-hmm.
And
And
then
again,
we have to prove our. Sir?
Yes. No, I wanted you to explain why are you saying it's an equation?
It's an equation because of our equal sign.
Okay, 100%. Just so that I explain to Kele, and again in the presence of Prudence. So in mathematics, generally we've got what we call an equation, and again we've got an expression. So there's a lesson that I've done where I explain all of this in detail. So when we've got an equation, that's where you see an equal sign, similar to that one over there. So when you've got an equation, it means you must solve for the unknown. So an unknown can be represented by any letter from A all the way up to Z. So there, in place of P, it could have been A, it could have been B, C, D, E, F, G, or any letter up to Z. So now that we notice we've got an equal sign, it means it's an equation. When we've got an equation, it means we must solve. What are we solving? We solve for the unknown. What is the unknown? An unknown can be represented by any letter, which is what I've just explained over there, to say it could be A, it could be B, or any letter up to Z. In this case, the problem is given with letter P. So that means we must solve for the unknown, of which in that case is P. And you are able to test if your final answer being P or an unknown, if it's wrong or correct, which is something that I'm going to show you guys shortly. And again, we've got an expression. So an expression is those type of problems which does not have equal sign. So that means there is no equal sign. So for example, you can be given, let's say maybe x to the power 2 plus x multiplied by 7 multiplied by y to the exponent 4, and this can also be divided maybe by x squared. So can you see here you do not have an equal sign, which means this is an expression, and when you've got an expression you simplify. So the second bullet there is that when you've got an expression, you simplify. How do you notice an expression? That is the most important part. If you don't see an equal sign on the given mathematical problem, you know it's an expression. If you see an equal sign, you know it's an equation. Then you follow all of this. But otherwise, for this one, which is an expression, you see there, you don't have an equal sign over there, which means it's an expression. Then you must simplify. So when you simplify, what exactly are you doing? You are simply rewriting or simplifying the whole of this from that complex number to a simplest number. You might find that the whole of this can be simplified to something like maybe x squared. So it's more like you are simplifying it from that complexity to its simplest form. So guys, before I start with that problem and other problems, do you guys have an idea of what I'm trying to explain over there? Tele and Prudence, can I get a response on that?
Yes, sir, we can clearly understand.
Tele? I'm not sure if Tele is having some connection difficulties or something related to that, but it's fine. So, ladies and gentlemen, we are given this problem. So the first question that you should ask yourself, it doesn't matter whether it's this type of a simple problem. The first thing that you need to ask yourself is that, is this an equation or an expression? Then you say, this is an equation. Why? Because you see an equal sign over there. So now that this is an equation, what does it mean? It means you must solve for the unknown. So what is the unknown? An unknown is that letter which can be letter A or anything all the way up to letter Z. But in this case, they represented the unknown as letter P, which means we have to solve for the value of P. What is the value? The value is a number, which means in the end, we must say letter is equals to a number. In short, what are we saying? We are saying our letter, which is P in that problem, must be equals to a number which could be a negative number, it could be 0, or it could be a positive number. So this is what we call a value. So a value is an actual number, which means whatever number that we get, it is represented by letter P in the original equation. So the reason why you need to be able to interpret the given problem is because it helps you to know how your final answer should look like. So now let's solve. When we solve, guys, remember, you can even write this to say you want to have the letters on the left side of the equal sign and have the numbers on the right side of the equal sign. So this thing, it automatically guides you in terms of how you should structure or rewrite your given problem, which means a promise on the left side of the equal sign, we want to remain with the letter or the letters representing the values. So obviously we've got negative P over there, which means we are going to write negative P, which is equals to, on the right, we already have positive 4, because now we are moving all the numbers to the right side. We are transposing. So remember, it has to change a sign from being negative 4 to being a positive 4. Very, very much important, guys. So which means negative P is equals to 4 plus 4, which is 8. But remember, we've got a negative 1P over there. The challenge that we are having is that this is a negative P and we just want P. And again, you know there's that invisible 1 over there, which is not necessary to write. So that is why for us to remove that negative, we are going to divide by negative 1. Remember, guys, whatever that you do on the left, you also do on the right. Why did you have to divide by negative 1? It's because you wanted to cancel that negative over there so that you remain with P, which is equals to negative 8. Can you see, guys? So that means the value of P is equals to negative 8. So you see, you've got letter on the left being equated to a number on the right side of the equal sign. So ladies and gentlemen, let's now prove if that answer is correct. For you to prove, you must say on the original equation, you must say negative 4, which is that one there, minus, which is one there, a P value. When you punch the whole of this, it has to give you 4, because on the original equation, they are simply saying what number, when you say negative 4 minus that number, will be equal to 4. So in this case, it seems like negative 8 is the answer based on our calculation. So when you punch all of this promise, it has to give you 4. If it doesn't give you 4, then it means that final answer is wrong, which is an indication that the whole of that calculation is wrong. So if this question is allocated 2 marks, you won't get a mark out of these steps. So guys, can you punch all of this and confirm if all of you are getting positive 4?
So it gives me positive 4, sir.
Tele Prudence, what answer are you getting?
Positive 4.
Okay, so it seems like it is a confirmation that it is positive 4. So remember, guys, for today's lesson, I'm mostly interested in teaching you the approach, not necessarily to answer these questions, because once you understand the approach, it applies to even more complicated stuff. So I'm going to do the same for the next question. So just remove that and rewrite that problem, which is 2y minus 3, it's equals to 17. So guys, what is this? This is an equation. Why am I saying it's an equation? Because I see an equal sign over there. What does it mean when you have an equation? It means you must solve for the unknown. What is the unknown? The unknown in this case is represented by letter Y. What does it mean? It means in the end, I must tell what is the value of Y. So in short, you still follow the same process, guys. You want to have the letters on the left, the letters or the letter, and equate it to a number, or otherwise numbers. So by that I mean, in some instances you might find that you need to find two values of the unknown, which will have two values. So obviously, for example, if you've got a different type of an equation, remember we've got a quadratic equation which can be seen by letter squared, and again you've got a linear equation which is just a letter to exponent 1, just like that one. You can see it's letter to exponent 1 over there. And again we've got a quadratic inequality, or we've got quadratic inequality or linear inequality. How do you notice those? An inequality can be seen by a sign of less than or greater than, or less than or is equals to, or greater than or is equals to. So you just need to be able to identify the type of a problem that you are dealing with. So in this case, it means I'm dealing with a linear equation. So when you got a linear equation, that's when you have one letter, one value. But if you've got a quadratic equation, that means you're going to have two letters and two values of x. Similarly, if you've got a quadratic inequality, you are going to have two values of x. If you've got a linear inequality, you are going to have one letter where you will provide one value for that letter. So guys, I hope that improves your understanding of how you deal with different types of mathematical problems. So for now, when I ask you a question, I'll be referring to it as a problem. Then you need to indicate what type of a problem it is. So now that I've indicated I'm dealing with a linear equation, then it means I must solve for the unknown, which is y. So in short, when you interpret this problem, it's more like they're asking you, what number, when you say 2 multiplied by that number and minus 3 will be equals to 17. You might know that number without you having to calculate. Let's check. When you say 2 times 10, it gives you 20. And when you subtract 3 from 20, it's equals to 17. So you cannot just say y is equals to 20 because you already know when you multiply 2 by 20, y is equals to 10. I meant to say, you cannot say y is equals to 10, knowingly that when you multiply 2 by 10 and minus 3, it gives you 17. You need to show by means of calculation. That's how you'll be scoring either 2 or 3 marks. So the reason why they don't accept it as just y is equals to 10, even though it could be a correct answer, is because there's a possibility that you could have copied from someone that final answer and did not bother to write all the steps because maybe you were running out of time. So we need to follow mathematical procedure to find the value of y. So at all times, you can firstly write to say letter is equals to a number. That's when you practice. So when you're in a test, exam, writing, assignment, or project, you must know in mind that this is generally what you're planning to do. So for me to have the letters on the left, that's if I can move all the numbers to the right. So when I move all the numbers to the right, whatever that remains on the left, you write it as it is. So on the left, I've got 2y, which is equals to, on the right, already there was 17. I'm only moving that 3 and it changes the sign, it becomes positive 3. So I can work out that and it gives me 20 because 17 plus 3 is equals to 20. Then I've got a problem of that 2 over there because what I want is to say y is equals to whatever number. So that means for me to remove that 2, I must divide by 2. Remember, what you do on the left, you do on the right. Why did I have to divide by 2? It's because I wanted those to cancel so that I remain with a letter which is y. So that divided by that is equals to 10. So can you see, guys? That means I have followed mathematical procedure to solve for the unknown, which is y. And the value of the unknown is 10. So now let's prove if 10 is the correct answer. That means you must say 2 into that 10 and you subtract 3. It must give you 17. Prudence, Shreyas, Tele. All that I've explained without asking you any question. Does it make sense? Is it clear? Do you now have an idea of how to approach this type of problems?
Yes, sir.
Okay, so when you substitute over there, what answer are you getting? Guys, are you still there?
Yes, sir.
So what
Yes,
answer
sir.
are you getting when you substitute over there?
So since 2 and in the brackets goes 10, minus 3 gives me positive 17.
100%, which means that positive 17, it is the correct answer for that problem. So now let's quickly do that one. It's a bit different but same approach. So I'm just going to quickly copy that to say 3 minus 4x is equals to 1. So with this type of a problem, it's an equation and it's a linear equation, and I see the unknown is represented by letter x. So I need to have the letters on the left equate them to the numbers, which means in the end I must tell what is the value of x. So to follow mathematical procedure, I need to move all the numbers to the right side of the equal sign. Whatever that remains on the left, I write it as it is. So which means I'm going to remain with negative 4x, which is equals to 1. That one, it goes to the other side, it changes the sign, it's minus 3. Which means I've got minus 4x, which is equals to, what is it? Negative 2. Then you can see I've got a challenge over there, Shreyas. What is my challenge? My challenge is negative 4. So I need to remove that negative 4. To remove it, that's when I have to divide by exactly that number. Remember, what you do on the left, you also do on the right. So I had to divide by negative 4 so that it cancels. So negative 2 divided by negative 4, I think it's positive half or positive 1 over 2. So what does it mean? It means when you punch 3 minus 4 into a half, which is 1 over 2, this must give you 1. And it does give you 1 because that divided by that is equals to 2. You've got that part which is 3 minus 2, and that is equals to 1. So guys, on this one also, are we on the same page? Does it make sense?
Yes, sir.
Okay, 100%. So now let's get to this type of problems, which is well known as simultaneous equations, where you need to solve for x and y simultaneously. So I'm also going to quickly copy that problem over there. So we've got minus 2y minus x, that's equals to 2. At the bottom, we've got 2x plus 2y, that's equals to 4. So remember, guys, you are given this problem and they say solve for x and y simultaneously. And again, let me also mention that this problem, guys, it just came out of my head. It's not really to say this is a valid problem. I just wanted you to notice the approach. So remember, guys, if you are given this type of a problem, and I think I might need to just make an adjustment on that problem. Let's make that one, let's make it 5. I'll also update on the original equation that I had to make it 5. The reason to that is because you've got a common factor of 2 there, 2 there. If it was 4, you've got 2 there. So it was going to be the same as x plus y is equals to 2. So that's why I had to change it to 5 so that out of all of those terms, we don't have a common factor. Okay, so guys, you are given this and they say solve for x and y simultaneously. So obviously, you need to have your equation number 1 and again equation number 2. In this case, you cannot use or apply what do you call it, that type of a simultaneous equation where you can say equation 2 minus equation 1. I think it should be elimination method. So you cannot apply that type of a method in this case, but instead you can use the substitution method. Why? Because you notice you've got that letter over there, which you can easily make the subject of the formula. So in short, guys, when you're dealing with simultaneous equations, you just need to make one term or one letter the subject of the formula. You can easily make x from that equation subject of the formula, which means you still need to have letters on the left, everything moved to the right. So let's see, when you move whatever that remains on the left.
Can you explain which method, like when we see a sum, which method must we use? Like, how must we know we must use a substitution method or elimination method?
Okay, so in this case, I would say if you can easily make a letter the subject of the formula, use substitution method. So if you've got a letter, it could be positive or negative letter A up to Z. Can you see? In this case, I've got letter X, which is negative letter X. Then I can use or apply substitution method. Normally when you've got, or normally when you need to apply elimination method, that's if, for example, you notice you've got a term which is the same in both equations. Let's say, for example, you've got 2x minus 7y, and this is equal to 30. And again, you've got, let's say, 3, let's say, plus 2x, it's equals to negative 1. So can you see, in this case, you've got that term over there, which is repeating itself on the other equation. This could be equation 1, this could be equation 2. So you've got that same term repeating itself. So remember, you can rewrite this thing as 2x plus and say it's equals to negative 1. This is still the same as equation number 2. You just rearranged that equation so that it's easy for you to notice if you can use the elimination or substitution method. So let me just remove all of that so that it makes a perfect sense. So can you see, you can now say either that equation minus that equation, because you know already this is going to, let's say we are saying which one, or maybe let's say we are saying this minus that, which is equation 1 minus equation 2. So obviously this subtract that, is equals to 0. Then you've got minus 7 or negative 7y, and you subtract 3, it's minus 3, which is equals to, you've got 30 minus negative 1, which is 30 minus into there, you've got a negative 1. So you can just work out the whole of this to calculate for the value of y. Once you know what is the value of y, you then substitute it. That's why, you then substitute it into one of these equations in order to find the value of x. So the reason why I had to start with today's lesson is because, can you see, when you have that type of a problem there, same questions still apply, guys. It's more like you've got a problem which you know it's a linear equation. Because of that equal sign, it makes it an equation, which means you must solve for the unknown. What is the unknown? The unknown is y in this case. What does it mean? It means in the end you must say y is equals to something. Obviously this and that, it gives a 31. Then you've got this, then you can move that, changes a sign, then you've got 34 on the right, which is equals to negative 7y. That one is just 0. Then you divide by negative 7 so that it cancels. Whatever you do on the left, you do on the right. Then you have the value of y, which could possibly be 34 over 7, which is what you are going to substitute into any of these equations in order for you to calculate the x value. So Tele, I'm not sure if I answered you to the level of your satisfaction. And again, Prudence and Tele, did that make sense, even though I was a bit fast in responding to that question?
Yes, it kind of makes sense. So for the above equations, the one you wrote, which is negative 2y, are you going to use the elimination method? Because you're going to say negative 2y plus 2y, that's going to give you 0.
So,
And then
which
solve for
means,
x.
which is a good question, especially for this type of a problem. But now, is it going to be an elimination method if you're going to say, because obviously you cannot say equation 1 minus equation 2 or equation 2 minus equation 1. Do you know why?
No, sir.
Okay, allow me to rearrange this one so that it makes perfect sense. Do you agree that based on what I've explained, this is the same as 2y plus 2x is equals to 5, which is still the same as equation 2. Do you all agree with me on this one?
Yes.
Shreyas, are you still following? Promise, are we still together, guys?
Yes, sir.
Okay, so if you agree with me that this is the same as that, let me now remove all of this. Let me all of this, and now we talk about this method. Are you going to subtract, or are you going to minus? Or no, you answer that question. So I was saying in this case, you cannot say equation 1 minus equation 2, or say equation 2 minus equation 1. Let's test it. If you say equation 1 minus equation 2, so when you get to these two, because they're almost the same, or otherwise they're the same, you are going to say, let's check equation 1. So it's more like you're saying minus 2y, and you subtract equation 2, which is 2y. So can you see, you did not eliminate that because you have negative 4y. I'm not sure if you get that part.
Yes, I got it. I also got negative
And
4y.
again, say again.
I also got negative 4y.
Okay, so that means even if we say equation 2 minus equation 1, you still have, let's see, it's going to be 2y, then you minus, equation 1 is over there, you've got minus 2y. So this still gives you, that times that is positive. Then you've got 2y plus 2y, which still gives you, what is it? Is it positive 4y? Do you see you did not eliminate that 2y? Can you see?
Yes, sir.
So
And
it
I've
only
also
gets
tried.
eliminated if you plus. So by that I mean, if you say either equation 1 plus equation 2, then you are going to add this plus that, and this plus that. That's how you can be able to eliminate the 2y. Even if you say equation 2 plus equation 1, you still get the same answer by eliminating that part. So it seems like in this case, you've got multiple choice of using the elimination method, or otherwise making either x the subject of the formula, and then from there you solve for the unknown. So this was plus 2y, it's equals to 5, and this was equation 2. So are you satisfied with that one, Ken?
Yes, sir.
Shreyas,
Yes,
does
sir.
it make sense?
Yes, sir.
Okay, 100%. So remember, guys, this is a simultaneous equation. I just want to teach you the approach. Remember, you've got equation 1 and equation 2. You need to use a less complicated equation to derive equation number 3. Listen to this very carefully, ladies and gentlemen. You need to use a less complicated equation to derive equation number 3. Between these two equations, which one seems to be less complicated? How do you notice a less complicated equation? It is that equation which has got either a positive or a negative letter. So you can note down that as part of your notes to say a less complicated equation will be seen by either a plus or a negative letter. For example, it's going to be a plus or a negative letter A. It could be A or B, C, D, or any letter up to Z. But normally for simultaneous equations, they like using a letter X or Y. So you can see between these two equations, it is that one over there, which is a minus x, which is a letter that you've got, which means this is a less complicated equation between those two. So now that you've identified a less complicated equation, then you can use it to derive equation number 3, which means you need to move everything else to the other side and remain with what you want to make the subject of the formula, which is x in this case. But remember, it's negative x, which means it's equals to, already there was a 2 there. You firstly write 2, then you add, because it changes the sign, it becomes positive y. Remember, you've got a problem, Shreyas, a problem of a negative over there. Divide by that negative 1. Remember, there's an invisible negative 1 over there. Divide by negative 1. Remember, what you do on the left, you also do on the right, which means you've got x, which is equals to negative 2. What is it going to be? I think it's going to be negative y. Then this is now your equation 3, which you can say equation 3 and substitute into equation number 2. Okay, so what I'm going to do now is just to show you the substitution part. So let's see, that means where you see x, you're going to substitute the whole of this, and then you say plus y over there on equation 2, and this is equals to 5. So guys, I'm giving you this as a homework to finalize until you give me the X and the Y values. So for that one, I'll just leave it there because I wanted to show you an approach. And obviously, we've done this type of problems where you can easily be able to solve for that one. Remember, guys, when you're given a homework, in case if you are that much busy with your schoolwork, you can just spare it aside, push your schoolwork, and at a later stage, remember to send that problem. So whenever you send it, I'll also have a look at it. So you can still attend upcoming lessons without you having done this homework. Just make sure that it doesn't disturb your schoolwork. So guys, otherwise, up to so far, does it make sense? Do you think you'll be able to take it further, this problem?
Yes, sir.
Yes, sir, but you confused me on why did you over there for X you put it in a fraction form.
Wait for oh, you're saying I've put it in a fraction form. Are you referring to that one there?
Yes, when you are dividing it. Yes.
Yeah, so
Aren't we supposed to
do you
just leave it like that?
But you know, the problem is when you leave it like that, it's negative x is equals to 2 plus 2y. And remember, you want to have a letter which is equals to either a number or whatever on the right. In this case, I cannot say a number because this is where we are making a letter the subject of the formula. So negative a, negative b, negative x, negative y, negative z. This is not a letter. It's only a letter if it's positive a, positive b, x, y, z. So you had to divide by -1 to remove that negative over there so that you have x, which is equals to the whole of that. So you can easily substitute it there because there you've got x, you don't have negative x. I'm not sure if it now makes sense.
Yes, sir. It makes sense.
So this is the tricky part about examiner giving you that type of a problem which has got a negative x over there. So it's just to confuse you with that negative sign. But you need to know that even though it's given as a negative, you must make it a positive sign. I knew it that if I made it a positive there, it was going to be easy for you and you wouldn't realize how to work it out in case if it's given as a negative. So I'm glad you asked that question, but now I've clarified it. You fully understand, isn't it?
Yes, sir.
Okay, 100%. So now I want to quickly get to this type of a factorization, of which this is what we haven't done, Shreyas, and I wanted to teach you how to factorize this type of problems. So I'm just going to quickly do that one, and maybe on our next lesson, I will need to teach you guys how to factorize this type of a factorization, because for you to be able to do all that you sent, Shreyas, you need to be able to understand all the type of factorizations. Then from there, everything will be just cancelling out themselves. So from what I've noticed, with this type where you don't have 1 there, but you have maybe 2, 3, 4, whatever number as the coefficient, they multiply that coefficient by a constant. So it's more like a coefficient multiplying the C value or the constant. So that times that, I think it's a 90. So now that you know you've got 90, they say what two numbers when you multiply together will give you 90 and still give you the middle term, which is 1. So what are those, guys? Let's quickly check. If you can be able to tell, you can just give me those factors. Let me start at 5. 5, it's not. Let me go to 6. 6 is 6 and 15. Let me skip to 7. It's a fraction. Let me skip to 10. 10 and 9. So that means 10 multiplied by 9 will give me that 90. And again, if I work out 10 and maybe say minus 9, they can give me a positive 1, which is that middle term over there. So that means I can rewrite the whole of this thing as 6x squared and say plus that, which is 10x, and say minus 9x, and say minus 5. So it's more like I've rewritten all of this problem in that manner, which is of course still the same thing, because 10 plus minus x, 9x, it takes you back to positive 1x. So what they do is to put all of this in brackets, and then from there take out a common factor. Let's see, what is a common factor? I'm not sure if, guys, can you be able to identify a common factor over there? Guys, are you still there?
Yes, sir. Yes, sir, we are.
Let me check. I think there's something somewhere that I need to sort out. I'm just wondering if we've got a common factor over there. Yeah, no, guys, I've just noticed something. I've actually copied this thing incorrectly. It has to be 15 over there and not 5. So it's 15 over there, but the same that I've explained, it's the same. So 6 multiplied by 15, it's 90, isn't it? Then you say,
yes, sir,
which two values when multiplied together will give you a 90? And when you say either those two numbers plus or a minus can end up giving you a positive 1. So 9. So now you rewrite it in that manner. Then from there, in brackets, you take out common factor. So here we've got a common factor of what is it? Is it 2x into, what are we having here? I think it's 3x plus 5. I'm not sure if you agree, guys. Then you've got that minus sign over there, which is that one there. Into, no, before I even say into, let's check if we've got a common factor on the second brackets. So there, I think we do have a common factor of 3, isn't it? Because 3, I think 3 times, what is that? 2, no, 3. I think 3 times 3 is 9. Then there's that x. Then let's check. There we've got a positive 5. Why a positive 5 is because when you say negative 3 times that, it takes you back to negative 9. When you say negative 3 times that, it takes you back to negative 15. Can you see? So you've got that and that again as a common factor. So you've got 3x plus 5 as a common factor. Then you can also put both of those in brackets, which is 2x minus 3. So can you see, you factorized the whole of this using your head. So guys, even though I was talking to myself here, did you understand? This is what I'm going to emphasize tomorrow, where I bring a lot more of different types of problems that we are going to work on, and I'll teach you in detail. But otherwise, did you understand that part?
Yes, sir.
Okay, 100%. So now, obviously, the last one, Shreyas, you know very well that it's very much easy. This is what we've been doing all along. So we've got x squared minus x minus 6. I hope I've copied it correctly. Yes. So obviously, you know this one. You focus on that term. So it's still the same thing. It's more like you say 1 multiplied by 6, which is 6. Then you say what two numbers when multiplied together will give you 6. You know, obviously 3 multiplied by 2 will end up giving you a 6, right? Which means that can be worked out together to give you the middle term being 1. That's if you say, for example, if you say 2 minus 3, this is going to give you what is it? Negative 1. So obviously, which means you already have x over there, x over there. You know 3 and 2, these are your factors. 3 and 2, these are your factors. So this is where you get the signs. If you don't want to say the bigger number takes the sign of the middle term, you know this is positive 2, this is minus 3, then you use the signs as they are. So in this way, you have factorized that expression or that problem over there. So guys, this is what brings us to the end of our lesson for today. I think at 1:15 I'll be starting with a lesson for grade 11 and 12. But otherwise, guys, are you happy with today's lesson? Are you not being confused by anything? Were you not being confused?
No, sir. I was happy with this lesson.
It was clear and straightforward, ne?
Yes, sir.
Yes.
Okay. Prudence level, are you guys okay there? Okay, guys, thanks for joining. Let me see. I think I'll just stop recording this lesson.